So we're looking at three different functions, and we're going to look at three parts of it. We're going to first look at our table, then we're going to look at what the equations look like, and then we're going to look at the graph of each of those looks like. And these are three functions that you need to be very, very familiar with. I'm just going through one example of each, and so in class you're going to be doing quite a bit more. But from what I go over on these three, it should be enough for you to be able to do what you need to do in class. For each of these, I have a table, the x and y value, typical t-table. And whenever you have a table, there's always, not always, there's usually going to be some kind of pattern. And so that's the first thing you're going to do when you see a table, or when you make a table, is you're going to start looking for that pattern. So on this first one, when I talk about pattern, there's two ways to look at a pattern. You could look across from x to y and see what are you doing to get from x to y. Or you could look at how do you go down on the y value and on the x value. Now the x value I have set up so we're going down by ones. So really for this, I'm just going to focus on the y value for now. As long as your x values are going at this constant rate here, we can just focus on the y values. It gets more complicated, of course, if that changes. So on this first one, I go down from 2 to 7, and I don't know yet because I haven't looked at the rest of the table if it's going to be adding, subtracting, multiplying, dividing, or more. And so I'm just going to go ahead with the obvious one, and that looks like it's going to be a plus 5. And so I'm hoping as I go on this table that it continues to be plus 5. So to get from 7 to 12, I would have to add 5. And to get from 12 to 17, I would have to add 5. And so it looks like my pattern continues. I'm going to check them all, though. I'm going to add 5. And so according to this, what I have so far on this table, it is going to be adding 5. Now here's what that tells you. If you're always adding the same amount every single time, okay, and that could be a negative number, you could add a negative number. If that's what's happening, then your function is a linear function. So on a table, if you add the same exact number every single time, it's considered to be a linear function. If I go to the next one, I go ahead and, oh, that looks like it's adding 2. Okay, and then on the next one I'm adding 5, which is not the same number, so it's not linear, but I'm going to keep going with this. And this one it looks like I'm adding 8. And on the next one I'm adding 11. Now at first you might not see a pattern to it, but there actually is a pattern to these loop-de numbers. That's what we call them here, is loop-de numbers. That is not a technical term. And so as I'm adding 2, I'm adding 5, I'm adding 8, I'm adding 11. It's not the same number over and over again, but there is a pattern to them. In fact, if I was to do the loop-des again, I would add 3, and then I would add 3, and then I would add 3. So actually I do have a pattern here of the same number over and over again, but that happens on the second time around. And so when it happens on the second time around, that is considered to be a quadratic function. Okay, and so again, if you have the same number over and over again on the second set of loop-des, it's quadratic. And that actually keeps on going. If it was the third set of loop-des, then it'd be cubic and so on. Now this third one here that we're going to focus on, if I were to go through and do adding, I would add 3, then I would add 6, then I would add 12, and then I would add 24. And actually, if you look at this, you'll see that I'm actually getting the same numbers as what I had in my table. And so what that means is I am not going to be having linear or quadratic here, and it's also not going to be adding. So I'm going to go to another operation. Let's look at multiplication. So here I multiply by 2, and then 6 to get to 12, I would multiply by 2, and 12 to 24, I'd multiply by 2, and 24 to 48, I'd multiply by 2. And so if you're multiplying over and over again by the exact same number, then what we call this is exponential. I totally spelled that wrong. No, not what I wanted to do. Exponential. Okay. So those are the three functions that we're focusing on here. You're going to be doing a lot of work with these. Now as far as the equations go, I have good news. Quadratic, don't worry about it. Okay? So we're not going to worry about an equation with quadratic. It's just more difficult to come up with, and you're not going to be asked to do that at any time. Linear, however, you are going to be asked to come up with that. And I know you've looked at linear functions before, but here's what's going on. You have x and y in your equation, and then you're going to have a number with the x. And then you're going to have plus another number. Okay, so the setup in linear is that you're going to be adding on some number to the x, and you have an x with the number. For exponential, you actually have two numbers also. You're going to have a number to the x power. So there's always going to be a number with the x. If we look at linear, the number with the x is being multiplied. If we look at exponential, the number with the x is the base of the exponent. So you need to remember that you have a number with the x, and then you have an additional number. On linear, your additional number is being added. On exponential, your additional number is being multiplied. Okay, so now what are those? Your number with the x is always going to be your looped number. It doesn't matter if you're talking linear or exponential. Your number with the x is always going to be your looped number. So that number right there is 5. Over here, it's 2. So I put a 2 there with the x. So again, that is going to be with the x, the looped number with the x. And then you have another number. And so your other number is going to be your y-intercept. And your y-intercept happens when x equals 0. So if you look, when x equals 0 on this first one, y equals 2. So this other number is 2. This is your y-intercept. And that'll happen for either one of them. So over here on the exponential, the x is 0 when y is 3. So 3 is your y-intercept. And that is how you find your equations. Now, what about the graphs? You should be aware of a graph already. A graph has a constant increase and of the linear, a graph of linear has a constant increase. And constant increase means that it's going steadily up or steadily down. There's not going to be a change in direction. It's not going to get rounded or anything like that. So that's what a linear looks like. A quadratic looks like a parabola. If you remember from Algebra 1, you have a parabola either open up or it could be open down. Has a change in direction just once. And exponential, that's going to be new to us. Exponential, what's happening is you have your y-intercept. And then if you've ever heard something increases exponentially, as the numbers get bigger, it's going to be going up. And it'll go up really, really fast. As the numbers get smaller, it's going to be going down. And actually, an exponential has this spot where it doesn't go beyond it. So if I look at the x-axis on this one, okay, my yellow graph here is going to get really close to the x-axis, but never actually cross it or even touch it, actually. It'll just get really, really close. And when that happens, that white line that it's getting really close to is called an asymptote. And so an exponential function has an asymptote. It can't go down any farther than what we have it set up as. It can't go past that asymptote. And so this is how the three functions that you're going to look at, this is their basic structure, and you're going to practice lots and lots with this.